Hello, my name is Evan Witz. This is section 12.3 of Math 219, Multivariable Calculus. So we are going to be working with the dot product today. If you have any questions that you'd like to see, feel free to post on the forums. Just as a note, we aren't going to be doing any of your homework problems, but if you see any problem in the book that maybe slightly similar to a problem that's in your homework or something like that, we're more than willing to do a problem such as that one. So we are going to prove that the diagonals of a rhombus are perpendicular using the concepts that we have learned about the dot product. So in case you're not familiar with what a rhombus is a four-sided shape. All of its side lengths are equal and the opposite angles are equal. So it's sort of like a square but tilted, basically. And what we're going to do is we're going to prove that the diagonals of the rhombus, which are the lines connecting the opposite corners of the rhombus, are equal to each other. So at this time, if you want to give the problem a shot, feel free to pause this video and give it a shot. So, yep. Okay, so in order to prove that the diagonals of this rhombus are perpendicular, we're first going to want to think about this problem in terms of vectors, because we're going to prove this using the dot product. So if I go ahead and make these two sides into vectors, and I'll call this vector v and this vector w, as so. Let me make those a little bit bigger. Vector v and vector w. There we go. Okay, so if you remember from your concepts of vector addition, this diagonal right here, if I go ahead and make a vector out of it too, this should be equal to v plus w, because vector addition is tip to tail. And similarly, if you go ahead and look at this vector right here, or this diagonal here, I'm going to go ahead and draw it as a vector as well. This vector should be equal to v minus w. Okay, so now we want to prove that these two vectors are orthogonal to each other, and the way that we do that is by using the concepts that we've learned about the dot product. So we're going to go ahead and take the dot product of these two vectors. So that's v plus w dotted with v minus w. Okay. So the dot product of these two vectors is as such, and since the dot product is distributive, we can go ahead and FOIL this. So this is equal to v dotted with itself. So that's first outer minus v dotted with w inner plus v dotted with w last minus w dotted with w. Okay, so it's sort of a difference of squares sort of thing. We end up getting the cancellation of two terms, and we just end up getting that this dot product is equal to v dotted with itself minus w dotted with itself. Now, if you remember, v is the vector that represents one of the sides of this rhombus, and w is the vector that represents the other side of this rhombus. So if we go ahead and work this out really quick. Sorry. So if you remember, any vector dotted with itself, the value that that gives you is just equal to the magnitude of that vector squared. So squared minus the magnitude of vector w squared. So if you remember, in a rhombus, all of the side lengths are equal. So in fact, magnitude of v is equal to the magnitude of w. So if you go ahead and make that substitution really quick, magnitude of b squared minus magnitude of b squared, which is just equal to 0. So that means that the dot product of v plus w and v minus w, the dot product of the two vectors that represent the diagonals of this rhombus, is equal to 0, and that means that the angle between them is equal to 90 degrees or pi over 2 radians, because the cosine of the angle because the dot product of those two vectors being equal to 0 means that the cosine of the angle between those two vectors is equal to 0, which implies that the angle is 90 degrees. So that proves that the diagonals of a rhombus are in fact perpendicular. So yeah, that concludes the problem for 12.3 that we have selected. If you have any suggestions for us to do outside of what you have on your class activities, we'll be more than willing to take any suggestions that you post in the forums. And thank you very much.